Cool. So you've already stolen like half my lines. I was going to ask how many people got them yesterday, and actually, so some questions that are non-rhetorical. These are actually going to affect what I talk about. How many of you actually have one with you now? Oh yeah, this is going to be a good group, I can tell. Okay, so the next non-rhetorical question I actually want to answer is, how many of you knew about Particle before the keynote yesterday? Oh, okay. So this is great. This means we're actually going to get to building some stuff and screwing around with some stuff instead of me talking at length about what Particle does. But I will go through the overview just for those of you who are new to this. As Marcus mentioned, I'm the VP of Product, which means I just care too much about too many things all the time. And I've been with Particle for about 2 years, so that's back when we were still called Spark. And we've done a bunch of other crazy stuff since those days. We feel pretty confident making the claim that we are the #1 platform for the Internet of Things, based largely on the size of our developer community. So much like Twilio, we really view ourselves in terms of our developers. It's not what clients we have, it's who builds on us. We're at about 75,000. That's a little bit of an old number, but we'll cross over 100,000 really soon here. So this is the way we like to think of the platform. So on the right side, all the hardware devices, because you have to have hardware to be on the Internet of Things. You have to connect in some way, so you come in through Wi-Fi or cellular. We actually have our own MVNO already, but we are so thrilled to be partnering with Twilio for our domestic service. It's going to get much cheaper. I think you'll all be very happy about that. And then we also have a bunch of other people's hardware. Several companies have built their own hardware development kits on our platform that use either Wi-Fi or other communication protocols like Bluetooth. In the middle, of course, is the meat of what we do, which is really just device management, taking care of the difficult parts of having a lot of hardware devices out in the field. That's how do you keep them connected to the internet? How do you keep them secure? How do you update the software that's on them and do that without bricking a whole bunch of devices like we've seen a couple of companies do in the last year or so? And how do you keep up with what's happening with them? How do you look at the health of the system? And how do you pipe the data to other places? And then on the right, see if I reversed that before, are all the services that we can interface with. It's really anyone. We have webhooks and nice REST APIs for everything. And we also have a bunch of SDKs in case you want to build native apps for mobile or web. So, in addition to that nice little API, we build a lot of development tools. We have a web IDE and a local IDE and a command line interface for doing all of the nitty-gritty stuff. And then we have a bunch of big, shiny tools on the web for the device management and the data management and setting data caps on your SIMs and looking at the billing and a bunch of the other things that you actually need. And then, like I said before, over-the-air firmware deployment. If I hadn't mentioned that already, being able to do the firmware stuff over the air is one of those really game-changing features. You don't need to go to a location to change what software a thing is running. You just push it. And if you happen to push bad software, the device will still recover. You push software that should brick it, it will try to run it, it'll have a problem, it'll get back online and be ready for you to roll back the software. Yeah, I mean, it's just critical features for a system like that. So we're also very, very fast. Our devices see sub-100 millisecond round trip, which is basically unheard of. We do that with a bunch of nice architecture behind the scenes. We run on 0MQ, but we also run our own encryption stack on top of everything. And this is kind of how we think about the progression of a consumer through our cycle. We have a developer or even like business consumers are increasingly on our platform. So you start out hacking, you get a thing, you plug some wires into it, you make something fun. Then you start prototyping where you're making something that's a little bit more solid, a little bit better, you're showing it to people. Then you start a small manufacturer run, you pilot it. You put out 100 devices or 10,000 devices, somewhere in that range usually. And you start using our management tools alongside to keep up with that and update people's software. And then you do bigger rollouts, 10,000 to 100,000 plus. And then managing everything out in the field. Oh, by the way, I don't think I gave this little sort of disclaimer at the beginning. Interrupt me, heckle me, talk to me. Like, anything you think of, any question, like, I don't have a particular flow or pattern, so you won't throw me off, and it'll be more interesting for everyone if you ask questions that fill in some gaps that I'm probably glossing over. Cool. So, yep, full stack, we actually go from metal down at the hardware end all the way up to nice UIs up at the top. We do all of the pieces. And then from the top, it goes out to other people's clouds. So we play nice with pretty much everyone. And most of the layers, you can actually substitute other people's products and use someone else's hardware. That's great. Someone else's firmware, totally fine too. You want to swap in somebody else's infrastructure or their interface. Great, we're happy about it. We work with everybody. It's part of us being friendly and us being interchangeable with a lot of things. So we have development services in case anyone actually wants to get something manufactured and produced. We're not going to do all the turnkey work for you, but we have great relationships with companies that do. A lot of companies that do prototyping, data services, because we're not trying to be the data player either. And of course, chip manufacturers love us. We've actually become Broadcom's development platform. So when the Broadcom sales guys go out, they give away our development kits. And this is, I don't even know why this slide is in here. This is clearly too small to read, right? All right, we got through that stuff. Let's actually mess around with some code. So, could I get the Elmo turned on? Could I get the Elmo on? Oh, yeah. Cool. So, some of you got these boards yesterday? Is this just like totally Blair Witch right now? So we make the Electron, this development kit, right here, which plugs into breadboards or sockets and is fully certified, so you don't have to worry about that stuff. And this is plugged into an Adafruit ring shield, so you can see all these LEDs around the outside. But interestingly, the ring shield wasn't actually made for Electrons. It was made to work with our Photon, which is our Wi-Fi development kit. So the Twilio guys put in a lot of effort and soldered on these headers and this totally crazy jumper wire that runs over and through the board and then back around to the back to make it work with the Electron. So just huge props to those guys. 200 of these things by hand. You can see that it's currently breathing cyan, which is our vocabulary for happy and online. And I've got a second one here too. So let me flip back over to my screen. So how about I get one of these to shout rainbows. So going all crazy rainbow colors now. Let's see if I can expand this. I have never actually tried to zoom in Atom. So if anyone has any tips about zooming in Atom. Yeah, I mean, of course I tried Command+. Come on now, that's just insulting. But I appreciate the heckle. What's that?
You might be able to do the pinch pull zoom on the trackpad.
I will try. Oh, good call. Winner. Okay, so you see these commands? These are ones that I've actually written beforehand. So if you look over in here, this is actual firmware code. This is what's running on the device. And the interesting part is here. So particle function is one of those ways that we expose things to the API. So here, for instance, we've got particle function LED on, which is what its sort of remote API name will be, and LED on remote, which is what the local function call will be. So that'll just pass through any commands, any payloads, any arguments to that local function. So we can figure out how LED on works, I mean, I guess right here in the comment. But we could also look into how it's actually operating. Let's see. This is one of my uglier, more complicated things, because just 30 minutes ago, I decided to port over this example that I usually use with the internet button, which is one of our other little products, to work with the Electron and the NeoPixel ring. So I haven't cut out all the extra stuff. Let's see. LED on should be really simple and really obvious. Yeah, I passed it? Yeah, so it's embedded C, which is interestingly LED all on. Yeah, call it row numbers. What? See, this is LED all on. LED off. I agree. I'm going to search for it next. There you go. God, you guys got to understand how tired I am at this point. Pulling that demo off for yesterday morning was some long time, and then we're coming off Maker Faire the weekend before. So this takes in the input, parses it into a string, and then turns the string into an integer, because embedded code is just like that. I'm so sorry for people who are used to JavaScript. Typed languages are just they take some extra work. So this checks to see if you wrote a color word like red, green, blue, or white in. And if not, it just goes ahead and makes it red, green, and blue in just in ints. And that turns the specified LED on. So now that we sort of know how that works, let's first turn all the LEDs off. And you'll see a slight lag because it's bouncing from here through the cell network and back. And it might not even be online right now.
So,
yes?
how did you make the connection to that? So for the ones that were out in circulation, was there a firmware that already, do you need to plug in to sort of sync up with it, or can you just, can anyone access your device?
Sure. So you want to know how to set them up?
Yeah, well, yeah.
Okay.
Well, just how you made the basic connection.
Sure. So the way that was actually set up was through our nice little web setup interface. So the way we do it is we actually establish a mapping. So you'll go through a nice flow like this when you want to claim them. We actually establish a mapping between the ICC ID, which is the SIM number, and the device ID, which is a hard-coded ID for the device, and use that to figure out the claiming. So we know who has what. So you go through here, and you will actually put in the ICC ID here, and then we'll figure out the mapping, so it just belongs to you. For the
Oh, sorry, do you need to be physically connected to it, or can you just be looking at it?
You do not. You can just be looking at it. Yeah, everything is remote and wireless. The way we actually did it for the demo was to claim them all to one of our organizations, which is the way we manage lots of devices at once. And that allows someone like Jeff or Evan to send a message out to all of them simultaneously, because otherwise he wouldn't own your device and he wouldn't have access to it. We've since unclaimed them, so they're all just yours, so you don't have to worry about that. No one's spying on you. And they actually couldn't really, even if they hadn't been unclaimed.
I thought the instructions and the flow was very good. I just followed right where you have it on the lanyard.
Yeah.
And that totally worked.
Good. Yeah, that's exactly what we were hoping for. So if you look at the URL on the lanyard, you'll get to here, and it'll walk you through the setup and how to claim it, how to make it your own. You do have to pull a SIM card out to pull the ICC ID. And then you'll be online, and you'll be kind of over where we are with the code. And I have so many tabs open. So I've just wiped all the lights off this. So let's say LED 10, and let's make it bright white. And now LED 10 is bright white. And if I turn them all off, nice, pretty fast. Oh yeah, most of the time it's really fast, but occasionally you get a little bit of lag in the cell network, and there's only so much we can do about that. It's actually one of the interesting things that you saw when we did the demo. You could see the messages get like bumped out through the cell network queue. So they don't hit simultaneously, but all definitely get there within 20 to 30 seconds. Cool. So just to further impress you with the speed, you see how it's breathing cyan? It's the little online thing. If I click flash on here, and it'll warn me that it may use some data, and I'll flash it over the air anyway. This is going to turn magenta once it actually gets up in the queue. Oh, it's the other one. Sorry. I had the other one clicked. And it's already flashed with new code before you really even get a chance to see it. That was actually one of the complaints that we've gotten recently is we greatly increased the speed of firmware over-the-air updates. And it's fast enough that if you aren't looking at it, you don't realize that it happened. And so people want us to leave some indicator up for a while just to prove that, no, that really worked. It's OK. I feel like I should be showing you guys more specific things. How about, well, what do you want to hear about, actually? Any asks? What's that?
Add a new feature.
Oh, God, add a new feature live right now? Just crazy, crazy. OK, I have one. How about, let me see, what does the subscribe handler look like? Well, how about you guys get to see the documentation while I write a new quick feature? Because I want to make sure I get the syntax right. It's always embarrassing when you have syntax wrong. So we have all these cloud functions. So I'm going to subscribe to a publish. We're going to do a nice little pub sub, which will let me control both of these at the same time. So how about I just copy this handler syntax because I'm lazy. And then how about LED? This is a bad idea. Very bad idea. They're going to be very, very bright.
Can you, in fact, make it less bright?
What, you want me to do that beforehand? I mean, don't you have to experience horrifically bright lights before you decide that it was a bad idea? Well, yes. So I could do like 50-50-50 instead of like something really, really bright. But let's try this. And let's see if this works. So I'll try compiling it. We'll see if I throw any errors. So this is all compiling on our build farm. So this goes out to our cloud stuff, gets compiled against our tool chain, so you don't actually have to maintain a local tool chain. I'm using the web interface partly to show it and partly because it's just convenient to not worry about it.
Does it still build on your tool chain with the local IDE?
So there's actually two ways to do it. You can build locally or you can build in the cloud. So
Building locally, can you just paste your code up in there?
yes. Let me try verifying again. I think you guys are hogging the internet. Oh yeah, there we go. Code verified. So let me click flash. We'll flash over the air. One of these two is going to go magenta. Oh, there we go. Quick little blink. Nice. And then we'll go over and select the other one, because I want them both running this code. Come on, which one of you two? This one. What's the question? Oh, yeah. Yeah. So that's one of the fleet management things that we do. Yes, sir. Oh, that's the 5-minute warning. That's not high.
No, it wasn't.
Oh, God. It was a bad idea. It was a terribly bad idea. So, yes, they've just been run. They are just ungodly bright. So these guys will run, 9 to 12 hours if you don't have the lights on, just with the radio on. That's not even putting it to sleep. That's not trying to do any good low power stuff. It runs for an hour and a half at this brightness. just ridiculously awful. And I made the critical error of not writing an LED off function there. So, hindsight, awful zoom, pinch. So I'm going to select the other one and also just turn it off remotely. If I selected the right one. There we go. Nice. All right, who keeps publishing to it? Because I know someone is. Now, what I could do is, believe is the wrong term. I am going to make that private. So by adding my devices, no one else can publish to these, because otherwise they're listening to the entire event stream from the rest of Particle, which lets you make a lot of devices interoperate. If you want things to play well together and coordinate, then they can subscribe to this public feed. Nice. That is private now. Let's get the other one turned off. I always assume that's going to happen with demos. If someone puts their phone number up on the screen, I assume that number just instantly becomes a trouble spot. Sure. It is not particularly managed. It's just open. Or do you mean as far as sort of sub-subscriptions? Yeah, but since I'm doing it on my devices, and since I've basically said I've got my own private deployment, so only messages coming from me will trigger them. And if I didn't do that, then pretty much anyone could just mess with it. There's another little trick we have here, which is I could preface this with something like, well, it's actually more of a publish trick. They are, but that will change in firmware 1.0.
You can send them privately, yes?
Yep. Yeah, so by default, they will be public. And that really reflects the early philosophy of the company, that everything would be open. And in fact, most of our stuff is still open source. The hardware designs are open source. The firmware is open source. A small version of the cloud deployment is open, and most of the tool stuff is open too. Yes, sir?
Can you speak a little bit about if folks are using it, integrating microphones, having local wake words, and integrating with speech-to-text services to sort of talk to devices?
Sure. That is definitely possible. We have a couple of people who have built them. If you look on the community, there are pretty well-documented projects for how to do that. And we may in the future integrate with a couple of those services that do it.
And they're looking into local wake words as well?
I don't actually know. I don't know how they're planning to do it. Couple more questions. Give me a couple more. Yes, sir. Yes, you can. So we can actually pull that data from the network. So you can do a cellular.locate function, which has been written, but I think not publicly exposed yet, to approximately locate the device without putting GPS on it. We additionally, I always have a bag full of goodies, it's just what I do, have a little asset tracker shield. So this has GPS and an accelerometer on it. So you don't have to keep the GPS on all the time. You don't have to keep the radio on all the time. Watch the accelerometer, see if it moves much. If it's moved a bunch, then pop online, report your new location, and otherwise, just leave it off. Don't waste the data. If you really want to track something. Cool. All right. Well, that was a wild and crazy ride through. And find me after, ask more questions. I hope I caused more questions to be asked than answered, because that's just a better conversation. Cool. Thank you.